welcome again to my channel. Today we'll solve another question from Leetcode. This one is 1561 and it is marked medium. Let's first understand what the question description is saying. So we are given an array of pile of coins, not coins but pile of coins. That means that um, if we are in this index and it has a value of 9, that means this pile has 9 coins. This one has 8 coins, this one has 7 coins, right? So this is an array of pile of coins. Okay, then the question wants us, so there are 3 persons, right? Let me write it. There are 3 persons: Alice, then Bob, and me. Okay, so the first step the question wants us to do is pick a pile, basically 3 piles for each person, right? So let's say I pick this pile. Okay, this means the question states that if I pick a pile, if I pick 3 piles, basically if I pick 3 piles, the pile containing the most numbers would be taken by Alice, right? The pile containing the most numbers will be taken by Alice. That means if I have chosen this pile, in this 3 piles, which is the most is the 9, right? The largest is the 9. That means 9 will be taken by Alice. Then the smallest will be taken by Bob, and the second largest or the middle one will be taken by me. This is the order of things, right? And what the question wants us to do is maximize the number of coins that I can take. That means that is that me gets, right? I have to maximize that. How to maximize that? We can maximize it because we are given the power of choosing the 3 piles that it is that we are choosing from, right? Let's say I take as a pile or 3 piles 9, 8, and let's say 2, right? Because we can take any pile. It's not like it has to be consecutive like 9, 8, and 7, 6, 5, 1, 2, 3, 4. Not like that. It can be any of the piles that we can combine, right? So in this case, the largest would of course be taken by Alice, right? Then the second largest will be taken by me, and the smallest will be taken by Bob. Now what's the difference between this pile and this pile, right? If you look closely, here also I got 8. Here also I'm getting 8. Bob got 7. Here Bob is getting 2, and that's the big difference. We are trying to minimize Bob when we are trying to maximize my collection, right? Because if we had chosen this pile, Bob would have taken 7, and in the near future when we move forward in the question, there would have been no chance of me getting 7 of me getting 7. I'll show you this more clearly, right? I'll show you this more clearly. Let's take piles, right? Let's say the first one that I chose was 9, 8, 1, right? And the second that I chose was 7, 6, 3, right? This is the second one, this is the first one, and I'm saying the first one, instead of choosing this, I would have chosen this, right? So see what I mean. If I would have chosen this one, Bob would have gotten this one, right? Bob would have gotten 1 and I would have gotten 8, right? I would have gotten 8. So if I take a counter here, let's say me, it would have been 8 till now, right? In the second state, Bob would have gotten this 3 and I would have gotten the 6. So by now I would have gotten 8 plus 6, right? If we followed this path, right? But what if we have followed this path? Let's see. So in this path, Bob would have gotten this one and I would have gotten this one, right? Same as before, 8. But if Bob had taken 7, that means 7, we would not have been able to use 7 here, right? In that case, 9 and 7 gone, 6 would be the highest. That means if we have to arrange this, it will be like 6 and 5 and whatever 4. Then I would have gotten a 5 instead of a 6, where I could have gotten a 6. So that is the logic of this question, right? Everything depends on me choosing the 3 piles and the way I choose it. If I choose it wisely, Bob will get less and I will get more. Because and Alice is out of the question because Alice always gets the highest, right? Alice, whichever is highest in the collection, Alice will get that. What I can optimize for is me getting the second highest and Bob getting a lesser number so that larger numbers are still left for me. That is the logic of this question. So let's dry run this, how we will solve this, and we'll see what I and you'll see what we can, how we can solve this, right? So I'll delete all this, right? So the first thing we are going to do is sort the array. Why? Because we want Bob to take the smallest numbers. That's the whole logic of our solving the question, right? We want Bob to take the smallest numbers, and for that we want the array to be sorted so that we can find the smallest numbers and the greatest numbers as well, right? So the sorted array will look like this. This is the sorted array, right? Now what we will say is, if you read the question, you'll notice that the array will always be divisible, the length of the array will always be divisible by 3, because the question says that let me show you, the minimum will be 3, right? And the size of the piles of coins is 3n. That means it is always divisible by 3. So it won't be like we take 3 3 3 and the last group we are left with 2. That will not happen, right? So we can safely divide this into groups of 3 without worrying about if it will fit or not, right? So that means without hesitation we can take 3 from anywhere, does not matter where, like does not matter like this, we can take anywhere, right? So what will we do? We will take the highest one, take the smallest one, and also the second highest, so that I get the maximum number possible, right? Just imagine if this was the array and we are in the first step, what is the highest number that I can get? The highest number that I can get would be 8, right? Would be 8, because the the highest number will be taken by Alice anyway. So the only option I have is the second highest. So we have to make sure the second highest goes to me, and the smallest should go to Bob. So the pile that will make is this one, 1 comma 8 comma 9. Similarly, the second pile that will make after this is 2 comma 6 comma 7, right? Let me cross out things for you so that it's easier. This gone, and this gone in the first step, right? Second step, next smallest number available, next highest number available, and the next second highest number available, gone. And lastly, it would be 3, 4 and 5. So everything taken, right? Now you'll notice the core logic of the question is this one, that we are always selecting the middle number. So the answer for this question is 6 plus 4 10 plus 8 18, which is the correct answer for this question. Now how do we do all of this is the next question we need to answer, right? How will we convert all of this into code? If you just look at these numbers, you'll find a pattern: 8, 6 and 4. Let's mark these numbers, right? Let's mark these numbers. Where are these? This one, and this one, right? So what are the indexes of these numbers? Let's see. 0 1 2 3. So this is third index, then fifth index, then seventh index. Do you see a pattern here? It's quite clear and logical also if you think about it. So what is the length of this array? The length of this array is 9, right? The length of this array is 9, and we are trying to make groups of 3. So how many groups can we make? How many paths can we make? Length divided by 3, because we're dividing into 3 groups, right? And the answer will be paths equal to 9 divided by 3, which gives us paths equal to 3. And that is what we see, right? We are having 3 collections. Out of these 3 collections, in every collection, Bob is getting one number, I am getting one number, and Alice is getting another number, right? That means however many paths are there, if there are 3 paths, Bob will get 3 numbers. And what are those numbers? Those numbers are the lowest 3. 1 2 3. If you check, or this will be 3, sorry, this is 3, right? So Bob will always get the lowest 3 numbers. And what will I get? I will get the second highest of all the available numbers, right? So out of 4 and 5, I get 4. Out of 6 and 7, I get 6. Out of 8 and 9, I get 8, right? How to do this? Just imagine this. We have 3 parts and 3 numbers are taken by Bob. After that, every other number is taken by me. Every other number is taken by me, right? So that will be the logic we'll be using to solve this question. So let's start coding. First of all, of course, we'll sort the array. Then we'll take an answer variable and set it to 0. Then we'll run a for loop, right? For I equal to paths, I less than length of piles, and I plus equal to 2, because we are hopping with a 2 gap, right? Now what are these paths? As I written already, paths is nothing but length of piles divided by 3, and we know for sure this division will will be complete because the question itself mentions that it is divisible by 3, right? So then we'll do simply answer plus equal to piles of I, and we'll return answer. That's what we do. We add every second number, every first number if you look at it, right? Now let's run this, and it's working. Let's submit it, and it is accepted. It is marked medium, but if you just dry run an example, and if you find the pattern, this pattern that we are always taking number in the gaps of 2, and the lowest numbers are being taken by Bob, so we can't take any of those numbers, then it's a pretty simple question, right? It is a greedy approach because we are minimizing Bob greedily, and then we are taking our answers, so you can say it's a greedy approach. But I would like to say that there's more of an observation approach if there is something like that, a pattern approach, right? So that's it for today. Thank you for watching, and subscribe if you like. I'll see you in the next one.